The context for this session is to introduce you holistically to talk about source code control. Okay. So it is either called source code control, it's called version control. What other words are they called? Usually people just say Git. Okay. Those are some of the words that you will hear when people are talking about source code control or version control. Okay. This session also has two parts. It has two parts. One part is where I'm going to talk about holistically to think about what is source code control or version control, what are the different parts of it, and that then Aarti will walk you through a hands-on experience with GitHub, okay, which happens to be one of the types of version control that's available. Okay. Okay. Any questions about the context? Okay, let's get started. Okay, what is source control system or version control system? Okay, the primary use case for this is it started as a tool that enables people to work on a single functionality, okay, without overwriting other people's rights. Okay, what does that mean? A very simple example that came to my mind. How many of you have used Google Docs? Okay, I need a thumbs up, thumbs down. Anybody use Google Docs? Okay. Mridula, you say you have used. Geetika, Charisma,
Yes,
Ritika.
ma'am. We have.
Okay, so does that mean everybody has used it? Okay,
Yes,
I need
ma'am.
it.
Yes, ma'am.
Okay, everybody has used it, right? Okay. And one of the functionality of Google Docs is multiple people can collaborate, meaning multiple people can write and read in Google Docs. Okay. So think of that as the basics of what a source control system is. Okay. So while Google Docs is usually for collaboration, sharing of documentation, source control system is for coding and any type of digital projects that you have. Okay, that's where you can use source control system. Okay. What are the different features that you see in Google Docs? Okay, first one is you can have multiple versions. Every time you do a write, right, it gets saved. Okay, when it gets saved, there's multiple versions of it. Okay, example is yourself, right? You as a human, you have multiple versions of yourself as you go in different phases of your growth. Okay, so it's the same, the phases are called versions. So when you start a document, it'll be just hello Prabita ma'am, right? And that could be, if you save it, it's one version of it. Okay, call it version 1. Then you can say, hello, Prabita ma'am, how's your day? You know, is it raining over there? And you can write a little more content and do another save. That becomes version 1. From 1, it becomes 2. Okay. So you can keep on, every time you save, it's a multiple version. Okay. And if you want to go to the previous version, suppose you have written all the way up to version 5 and you decide, you know, I don't want to share my version 5 with Prabita ma'am. I want to give her version 4, which is a previous version to what you wrote. You can actually save, go to that version. Okay. Every time you save in Google Docs or any time you save in the source control system, it associates a number that will enable you to go back to any versions of the past. Okay, so that's one main reason why people talk about source control system. as they collaborate on a code. The second one is, of course, the most common one. Maybe I should have put this as my number one bullet, is the primary reason why the source control system or the version control system exists is to enable multiple people to work on a single functionality. Okay. Aarti ma'am will talk about how you don't tend to overwrite on it because each of you will have a local copy. And then when you finally think about merging the copy, then it becomes one consolidated copy. Okay, we'll talk about how it enables multiple people to work on the same project. Okay. Now, the third thing that most of big companies use, one of the primary use case that we use is as you save into this document, what it also saves with it is it also tells who has been doing what change. Similar as Google Docs, right? You can, if somebody's changed it, you can actually go to the history, right? And you can see who did, you can go to the previous version in your history. And when you click on it, you'll see exactly the change that was done by who. That's exactly the same theory that is applied to source control or version control systems, except instead of documentation, it is applied for coding. Okay. Any questions? This is the foundation of source control system. Any questions?
No, ma'am. No, ma'am.
Okay, clear, right? Okay, awesome. Okay. Now, what this is basically, this is exactly how you see that picture. That picture is how most of companies will work. Okay. You will have one project and multiple people will be working on it. Okay. Now there'll be one person who will be reading the file, one person who will be writing, one person will be starting the file, another person will be reading the file, then another person will be overwriting the changes, or another person will be adding more changes. Okay. So all this has to be coordinated. And what happens if you do not have that coordination? What challenges do you think that will happen? First is people will be overwriting on each other. Okay, that's number one. The second one is the versioning is very, very important. Okay, especially when you work on coding projects, versioning is very important because at any given time, when you build a product, a particular version will be available to your customers or to your, whoever is using your functionality. Okay. Call that version as, let's say, we'll say that version number is N. Okay. There's always N minus 1, which is the previous version. Okay. There's also a version that you will be working on after you release a product, which is called N plus 1. Any confusions with the N minus 1, and N plus 1?
No, ma'am.
Okay. Now, when you're working through this, right? Suppose your product that has introduced a defect or a bug. What will quickly give you that, because of the versioning, you already had a previous version. This is N-1, which was your previous version that your customers were using. Then you introduce this version called N. Okay. So if you have an issue like that, what most of the companies quickly will do, rather than trying to fix the issue, they'll go to a previous version. This is called rollback. Okay. Just keep it in your mind, not to complicate things. It's called rollback, where they'll go to a previous version. Okay. As you go to big companies, versioning is actually, it's a strategy that people will build. Okay. When I was working in PayPal, okay? Financial. You guys have used PayPal, right? You guys know about PayPal. Does anybody not know about PayPal?
No, ma'am.
Okay.
No.
Okay, you know about PayPal, right?
Yes,
Or
ma'am.
it could be, yeah, okay. Or it could be any financial, okay? We had a team of almost 12 to 14 people at any given time whose complete job was to make sure this versioning was in synchronization, okay? Because each different part of the project had different type of functionality. And when you as a customer come, right, to use PayPal, one person will be trying to pay you. You will be paying to somebody else, okay? There's different functionality. And because there's different functionalities, there were different teams that were working on their own on each of those functionality. But when we released the product, we could combine all of them and we release them into one module. So when you go to use PayPal, you don't have to think, am I using this functionality? Am I doing the update functionality? Am I creating the functionality? Nothing like that. Your money, you can do it. Either you can pay somebody, somebody can pay you, and all those things. Okay. Now, internally, what we had to do is we had a complete release or versioning strategy such that there was no overwrite on from each other. There was good code best practices that were followed in each of those modules. Okay. And this was all possible because of the versioning. Okay. If you there's a really good article, and even if you go to ChatGPT and just do, versioning of projects or software projects, you'll see a big article on it. Okay. So there are a lot of ways that companies do, and each company has a different way of doing versioning. Okay. But foundation wise, it's the same. You have n minus 1, and n plus 1, and it can go all the way back and forth. Okay. So what is the challenge? The first is because code conflicts can happen. Okay. Lack of versioning can happen. With all this, what happens is people will not be able to collaborate and write on the project, okay, together. Last one is something I threw in over here. I'm not sure whether, you're ready for this, but I will, when you go for an interview, usually they'll ask this too. Okay, so writing is all one aspect of it. Creating code is one aspect of it. But remember what I said when we worked at PayPal, there was a release management and a versioning management strategy. Now, at the end of all this is because there has to be all these versions have to come together. At the end, when you send the product or the project over to a customer, it's called deployment. Okay, that's the terminology. That's a technical terminology. Okay. And that is basically to get your code to your customer. Okay. And versioning and source control all play a very important part in it. Did I confuse anybody over here? Okay. Okay. Now, some of the key features, and Aarti ma'am will actually show this with hands-on experience. Some of the key features of all this is, usually source control systems have a terminology called repositories. Okay. Or they call them short term is repos. Okay. Something that these are all terminologies that you should know if you're going to present yourself in an interview saying that I have experience with source control. Okay. So repositories are nothing but, think about the source control itself is a big bag. Okay. A big basket. Okay. Inside that basket are multiple sections. Okay. And each of the section can hold things. Okay. Like your purse. Okay. Important is your purse. Okay. Or your backpack. You have a big backpack, but it has multiple sections. Okay. And each of the sections have different use and different things that they contain. It's the same thing. So repos are nothing but repositories are nothing but different sections in your bag. They hold different type of projects or different type of functionalities. Okay, those are called repos. Now, once a repo is defined, what happens is, think about this. As you are going to code, okay, you usually will not be coding in the uh, main trunk. Okay, that's what it's called. Okay, just like a tree, right? So there's a main trunk. Okay, usually this main trunk, right? If you chop off the main trunk, your tree is dead. Okay, so people will not usually do any type of changes on the trunk. What they will do is they will take multiple branches, just like a tree has multiple branches. They will once you want to make a change to your trunk, you will take a branch. Okay, you will create a branch of the tree. The tree is still the same tree. Okay, so the tree still remains the same tree. Just because a branch comes out of the tree, it does not change. It's still the same tree. Okay, and then what people do is they work off that branch. They will make changes to uh, all the things that they want to make change for in the main trunk. Okay, and that is called a branch. Okay, when they do that branch, okay, there are different ways that people will do. You know, when Dr. Aarti ma'am does hands-on, you'll see how it all works together. So there's a trunk, the main tree, and then there's branches. On the branches, people will be able to make changes, which is when they make the change, they will pull whatever, whatever file that they want to make a change to, and then they'll edit the file and then they'll commit it to the branch. Okay, I wish there was a whiteboard for this, but think about this. Okay, a couple of important terminologies that you need to know is just like a backpack. Okay, the entire backpack is your version control system. Then different sections in it are called repositories, and each of the sections can hold different type of content. Okay, and the way that you think about versioning control itself is the main is usually, or they call it, some people will call it main, or they'll call it master. That is your trunk. Okay, that people should not be making changes. Usually you'll take a branch, you'll pull file out of that branch to make a change. You make the change and you commit the change. Okay, any doubt about the key features?
No, ma'am.
Okay. Okay. Now,
I just
yes.
I just put a photo in your chat if you want to copy that or show it to the students if you can, or they can
Oh,
also.
yeah, that's a perfect one. I let Aarti sort of explain this as she's walking through the hands-on. I think that's a real good picture. Okay.
And Pravita, there is a whiteboard on Zoom if you want to use it.
Okay. Okay. Good to know. Okay. But you guys can see this. It's a little bit more complicated, this picture, but I think you'll get the idea of it. You know, it's pretty straightforward to me, but look at it, and as you do the hands-on, maybe it'll have more relevance to what that picture is.
So one question, Prabita, when you are saying that you make the changes in the branch and then you commit it and then it goes into the trunk. So that means the trunk has changed, right?
Yeah, that is where the merge is. I didn't want to introduce the word merge. I just felt bad about. Yeah, there is a word. There is a command to merge it. So you take from the branch, from the trunk. You take from the master or the main. You take a branch. You make your changes. You pull your files that you want to make changes. Then you commit into the branch, and then you have to bring. It is called the merging. Okay, and the merge is where most of the issues are. That's why most of the companies will fail if they don't have a right merging strategy. Because think about it, all multiple branches are going. At any given time, they all have to merge into this main trunk. Okay. Sometimes there are merge conflicts that have to be resolved and everything. There is timing associated with it. Um, that's also where auditability comes into thing. At the end of it, at any given time, your master or your main is the system of truth for your product. Okay. So usually, I told you, right, in PayPal we had 12 to 14 people. They're out of that 12 to 14 people, 5 people, their own entire job is to make sure at any given time that trunk was not broken. If the trunk was broken, the main branch or the master was broken, you will be assured the head of the department will be fired the next day. Okay, that's how important that master or the main was. Okay.
Thanks.
Yeah. Charisma, Stella, Ritika, questions? Afrida, questions?
No, ma'am.
Okay, you get this, then everything else is very the foundations. You get the foundations of how the system is and what the system is. Then going forward, it's pretty easy. Okay. Now, why it is easy is popular systems. Okay, this is the foundation of how things work. It doesn't matter where you go. Okay, most of the companies use a repository type called Git. Okay, Git is the foundation of this entire tool set that we are talking about, the version control, source control. And usually we are talking about GitHub, right? I've not used too much of GitHub because GitHub is, something that just got popular recently, but when I used to code, mostly we had GitLab. Okay. And also SVN was another one that we used a lot. Okay, now there is GitHub, but foundation of GitHub, GitLab, or Bitbucket, they all use Git. Okay, so if you want to learn or get more hands-on, okay, it could be any of the systems like GitHub, GitLab, Bitbucket is also another one. Or I'm not sure how much of folks actually use Apache Subversion, but usually the product is, I think it's open source and it's pretty solid. Okay. Any questions?
Are all of these free versions?
No. GitHub is the most expensive one that I can think of. Okay. GitHub is not free. GitHub might have an open source version, but usually companies go with enterprise. GitLab is usually free, but they have different type of support models. Bitbucket, I'm not sure. Okay. Apache is usually free. Okay. If any of this is free, Aarti? I know for sure GitLab is free.
I think all of them have, well, at least both GitHub
Version.
and GitLab have both free and paid versions. So
Yeah.
GitHub is actually very popular, mainly because it offers a lot of free features, particularly for the open source community. So most open source projects tend to be hosted on GitHub because it has enough free features for open source.
And most of big companies actually use GitHub because of the very thing that Aarti mentioned. They are feature rich. Okay. I know for sure we did a project for the White House over here, and everything was GitHub because they also have very they have a lot of compliance and security built into them. Okay, so with that, I'm going to hand it off to Aarti to actually go through the hands-on experience. Okay, give me 1 second.
All right.
Do you want me to
Thank you,
still continue
Pravita.
sharing the thing, or do you want to do it?
I think I can do
Okay,
it, but I'll just share my whole screen, I think.
okay, I'm going to stop. Yeah. Okay. And you want everybody on the camera, right, Aarti?
Yes, please turn on your cameras. While let me figure out how to share. Okay, there we go. Okay, can everyone see my screen?
Yes, ma'am.
Okay, good. Okay, so before we get started, did everyone complete the prerequisites? Do you have your command prompt ready? Are you all at your computers? Have your command prompt ready? Have your project code ready? Have your GitHub credentials ready? Can I get some confirmations?
Yes, ma'am.
Okay. Okay, so just an introduction. This is what I'm going to show during this demo. So we're going to focus on GitHub. So I'm going to take you through some basic workflows that you would use when you start using Git and GitHub. So we'll cover some of the fundamentals of Git. So Pravita already explained some of the basic terminology for Git. So we'll go through each of those and see what they mean in practical terms. And then we'll go through a very common team-based workflow on GitHub. So that involves the branching and the merging. So we'll do all of that. So the way this is going to work, so for each of these steps, so we'll go through each of these steps one by one. The first one, which is creating the repository, I'll be the only one who'll do that. So that's just the shared central repository. So I'll show you how it's done, but I'll do that. And then for each of the next steps, I will do it and show you how it's done. And then we will pause so that you can all do the same steps on your machines to try it out as well. And then we'll move on to the next steps. And also, if you have any questions, you can feel free to ask at any time. Okay, so here, looking at the steps here. So the first thing we're going to do is create a repository on GitHub. So like Pravita mentioned, so a repository is like a bag, or it's a section. So it's for your project. So you would create a repository for one project and then another repository for another project. So sometimes it depends on the company and how they structure their code. Sometimes they might have a single repository for their entire application, or sometimes they might break up their application into different modules, and each module might have a repository. So that's dependent on how the company has decided to set up their code. But ultimately, a repository it's a project. However, it's like an organizational structure, and it comes with it will contain your code, the files. It also will have the version control and the history. It'll have the branches. It'll have the commits. and you'll be able to make changes. You'll be creating so moving on to that second step there, you will clone the repository, which means you will create a local copy of the entire repository. What that means is that you will get not only the code, but also all those Git features like the branches and the commits and the version history as well. So usually if you see local, that means it's your local repository, so what's on your machine. And remote means what's not on your machine. So usually it's hosted on GitHub or GitLab or Bitbucket or whatever. But so somewhere on the cloud, that's hosted by by someone else. So that's the remote. And there's a process of syncing back and forth between the remote and the local. And then I will come back to the other steps later. So let's focus on these two steps first. So the remote and local. So I'm going to set up the remote first, and then I'm going to clone it into my local. And then you will also follow the same step. And by the way, here's my cat. So I'm here on GitHub, so you should all have access to this organization called I believe I can. And in GitHub, so actually, let me give you a quick tour of GitHub. So when you sign in, you should see something like this, your homepage. So you'll have your user account. And in your user account, you can create your repositories. So I actually, as homework, you should do this. So you already have a GitHub account. You have a project that you built on Python. You should put that project on and host it on GitHub so that your potential employers can see it. It's good for your resume to have a GitHub link and showcase your projects there. So, once we go through this workshop, maybe next week, you should go and create your own repository and put your code there. But today we're going to go focus on the organization. So on GitHub, you can have your personal user account and your personal repositories, but it also allows you to create an organization. So any company, if they're using GitHub, they would create an organization, so that way it makes it easy to collaborate with a team. So that's, I invited you all to the team. So if I go to people, you should see all of your names here. So this is our organization team. And then here is where you'll see the repositories. So right now there's none, but I will create the first one here. So let me call it Maristella. I'll make it public for now. I'm going to add a README. So this is it'll just add us the first file. And it says it's going to set main as the default branch. So this is what Prabita mentioned as the trunk. So the default branch is going to be called main. We created. Now you can see, so the main thing in a repository is code. So you can see here that I created, when I created the repository, because I clicked README, it created a README file. And if you look at this file, it just has the name of the repository. So nothing much to it for now. But so this is the remote repository. So let me just go back to this slide over here. So throughout this workshop, so Git as a system, it has kind of 4 areas or 4 places where your code moves through. So the remote repository is what I showed you. That's on on GitHub. And then the second thing I'm going to create is the local repository. So that will be on my local machine. So you can see all 3 of these are local. So there's the local repository, but then there's also the working directory. Working directory just means that those are the files that you're working with. You'll usually work with them in your code editor. And the staging area is kind of like a draft area. It's a bit hard to explain, but when we get to committing files, I'll explain that a bit more. But right now, just remember that remote is a separate area. Local is like a copy of that remote, and you're going to be using different Git commands to move code between these areas. So we have our remote. Now I'm going to go and get it in my local. How do I do that? So any GitHub repository that you see on GitHub, so there's a lot of open source ones you can see as well, but they will have something called code over here, and it says clone, and there's a link. So I'm going to copy that link. And then, so I have a code editor. Hopefully you all have some kind of code editor. I'm using VS Code. And in VS Code, I have a command prompt. So you can use a separate command prompt. It should work the same. So the first command I'm going to do is git clone, and then I'm pasted that URL that I copied from GitHub. So when I do that, it said it's cloning into Maristella. So now if I do, if I see my files, I see there's a folder called Maristella. So let me show you what that folder contains. So this is my local file system. And in Maristella, I can see there's a readme.md. And that is the same exact readme file that was on GitHub. So now I've created a copy of everything that's in that repository. Now, something to keep in mind, if you only see this file, but there's actually a hidden folder in here as well. So what I did right now is I hit a shortcut on my computer to show hidden files. I don't know exactly how that works on Windows, but when you clone the repository, there will be a hidden folder called .git. So generally, you should never touch it. Don't go funking around it. Don't change anything there. It's like Git's, but this is where Git stores all of its features. All of the commits, all of the branches, all the history. This is where it's stored. But this also is what actually makes this folder a Git repository. So it's not just a regular folder. It's a Git repository because Git has some additional features that is attaching to this folder. I'm going to turn off this hidden files. So I'm going to pause here. Any questions so far?
So whatever changes you make in the clone folder gets replicated in the GitHub?
Not automatically. So these
Okay.
four areas that I showed. So it is your responsibility to sync between the local repository and the remote repository. It won't automatically do that for you. And thinking about that, the reason for that is it means that you can say you're working without an internet connection. So you could have cloned the remote repository. Now you have all of the features of Git. You can work locally on your laptop. You don't need an internet connection. And when you do have an internet connection again, then you can sync back to the remote. So even though this is a network-based system, you're pushing and pulling between your local and some cloud system. You can still use all of the Git features locally without needing any internet connectivity. But again, it is the developer responsibility to move code between these two areas when it makes sense.
Okay, thanks.
And usually, I think, Serena, you bring up a good point. So usually, the reason that people do local copies, one is to work offline, the other is so people get to play, when they code, they will test it locally to make sure that it runs locally. It could be, for example, a document, right? You do your spell check and all those things. Once you're ready, you can sort of push it into the remote. Because once it goes to remote, then there's easy accessibility for you to push it to your main.
Okay.
Anybody
And then
from Maristella? You guys have been very quiet. Is this too confusing? Is there anything that we want to sort of revisit from what Aarti ma'am is talking about?
Ma'am, can you repeat it, ma'am?
Yeah, okay. That's what I thought. Yeah. So, you know what? Let me be very clear. Even if it means that we have to spin off another session, that's completely fine. But what you learn over here, you need to learn, okay? You need to open your mouth. And if you don't get it, because I didn't understand the first time I learned about this, trust me, I did not. Okay. So do you want from the beginning or which part do you want to be repeated, Afrida?
When I'm starting.
Repeat what you just said. Oh, when Aarti ma'am started. Okay, Aarti. I think they want you to repeat when you started.
Okay. Which part? Wait, which parts were confusing? What did you get so far? And it's okay if you don't understand everything, but I know it's a lot. This diagram, you don't have to know everything about this diagram yet. We'll go step by step. Right now, all you have to know is that there is a repository on GitHub called Maristella. I copied over this URL and I pasted it in my command prompt with git clone. And what it did is it created a local repository. So it created a local copy of what's here. So my VS Code. So I'm going to actually open this folder here in VS Code as well. Okay. So now I have the same folder. It just has the one file. There's nothing in this project yet. It just has a README file and it just has the name of the project in this file. We haven't added any coding yet, any descriptions yet. So we'll do that step by step. But right now we just have two things. We have a GitHub remote repository and I have a local repository. So actually the next step is for you all to do the same and get a local repository on your own computers. So shall we do that? So that's the first task for you. So similar to what I did, I want you to do the git clone. So actually I can paste this somewhere convenient for you. So this is the command you should run. I'll paste it on Zoom. I can figure out how to work Zoom. Where do I see the chat for Zoom?
Right at the bottom, you should see. Do you see audio, video participants? Or maybe that's
No,
because
I'm in
is
sharing mode.
Yeah. I think when you share, it gets hidden. Do you want to stop the share and just put it? Yeah.
Oh, okay. It's at the top here.
Yeah.
Okay. Nope. Sorry, I want to paste this entire thing. So first of all, can you all access this GitHub page? So why don't you all try going to this GitHub page to make sure you can see it. Okay, is anyone able to access it? Are you able to go to the GitHub link?
Rita, are you able to go to that link?
Ma'am.
Does it work for you?
Yes, ma'am, it is working.
Okay, so once you confirm that you can access this, the second step is in your command prompt, type this command, and then you should be able to see the same folder that I showed you. So you should see a Maristella folder created, and it will have the same README file created. And tell me once you've done that.
Maybe we should get a thumbs up from all of them to see that they are at the right spot, Aarti.
Yeah, so once you are able to run this command, yeah, give a thumbs up. And if you're having trouble, speak up. We can help. I see Stella on camera. Stella, were you able to get it working? Thank you for turning your camera on. Yes?
We are trying, ma'am.
Okay.
Ma'am, do we need to paste this code in VS Code?
Do you have VS Code? You can. So if you, it has to be on a command prompt. So whether it's your Windows command prompt or whether VS Code also has a command prompt, you can type it in either. Are you all using VS Code?
Ma'am.
I didn't hear that, whether that was a yes or a no.
So Aarti, can they use any other editor or does it have to be VS Code? It could be anything, right?
No. It could be anything. Actually, it doesn't even have to be an editor to type the commands in. It doesn't have to be a code editor. So on Windows, you can just open your command prompt and type it there.
Does that make sense, Stella, Geetika, Afrida? Do one of you want to share your screen as well? Mridula, Titika, Jessica, Karishma.
Okay.
Ma'am,
everybody.
Lahari is sharing her screen, ma'am.
Okay, great. Thank you, Lahari.
Or do we need to stop sharing your screen, Aarti, for them to share?
Yeah, I'll do that. Great. Yeah, that looks like you have it working. Perfect. That's all. Yeah. So now, sorry, go ahead.
Yes, ma'am, it's working.
Okay. So that is now your local repository. And we are going to, as we work through this workshop, we're going to add your code there, and then we're going to push to GitHub. But right now, that's all we need. So we have the GitHub remote repository, and each of us has a local repository. So are you all going to follow and type, or do you just want to work on Lahari's computer? How do you want to do it?
Ma'am, can you repeat what you just said?
Oh, do you all want to try out the code on your own computers, or do you just want to see one person do it? So maybe just Lahari can follow the code and type it on her computer. How do you want to do the workshop? So either all of you can sit on your computers and do the same steps that I mentioned, or you can all congregate around one person to try it on your side.
We all want to follow, ma'am.
Okay, that's great. So is it working for all of you then, the git clone?
Yes, ma'am.
Okay. Okay, then I will move on to the next step. Okay, so the next thing I want to show you is what a commit looks like. So here it actually says there's an initial commit. That's just what GitHub creates by default. It'll just create a commit. But I want to just show you, I'm going to directly edit the file on GitHub, and then I'm going to show you what a commit and a commit history looks like. Now I'm going to do it directly on GitHub. Now I do want to say that this is not common. So in general, you don't edit files directly on the remote repository, but I'm just going to do it for demonstration purposes, just so that I can show you what a version history looks like before we go on and create commits locally. So I'm just going to create some text here. So a README file is like a description file for the project. So you generally it would contain, you know, what this repository is about, what the project is about, who's contributing to it. So I just added a quick one line, and here it says it changes. So what I'm doing now is I'm going to create a commit. So a commit is like a save. It's like an official save. It means that it's creating a point in history, and because it's not like saving a folder, a file on your folder, because it's a bit more, I don't know, official than that. Like you're saying that this is an important place in history that maybe I want to come back to later. So it's important that you write a commit message that's meaningful. It should say what your changes represent, what you did in your changes. So, you know, usually your changes will be to your code files. So when you create a commit for those changes, you should describe what those, what you changed. Like maybe it might be something like I've fixed the bug in this page, or maybe you say you have one of you had the weather app, and you said, you know, you had to handle invalid inputs. So maybe when you did that, your commit message might be handled invalid inputs. So you're describing exactly the changes that you did. So in this case, all I did was added a description. So I'm just going to say added description. But my point is that you should make sure your commit messages are meaningful. And you can add a lot more details here as well, if that makes sense. So right now it says it's committing directly to the main branch. Now, if you remember what Prabita said, the main branch is very important. Usually developers don't commit directly to the main branch. So I'm only doing this for demonstration purposes. So now I changed this file. You can see that the file has the new message, but what I really want to show is this commits. So it has two commits now. The first is what GitHub initially created. The second is the commit I just created. So if I click into it, I can see the change that I made here. So the red means the line was removed, and the green means the lines were added. So even though the first line is the same, it's just a way to visualize how that line changed. So in this case, there was a new line character added, and then this new line was added. So I'm going to just do that, repeat that process one more time. So I'm going to add another line. And then I'm going to commit again. Add a message, and then I committed its changes. So all I'm doing here is I'm creating commits. I'm creating versions of this file. So it's like how Prabita described you, like Google Docs, right? So initially I just had the title, and then I added one line, and I want that to be a version. And then I added this other line, and I wanted that to be another version. So if I go back to see the commits, so there's another commit, and I can see that it shows me the lines that I added in this commit. So the reason I'm showing you this is your version history. So this is what your repository history will look like. So it's like a log of every single change that anyone committed to this repository. So in this case, it's just me. So it tells me that I was the one who committed this 1 minute ago. So you can imagine that as more developers work on this repository, you're all going to have commits here. And each commit is going to describe exactly what changed, who made the change, when it was made. And if you click into it, you can see exactly all the files and all the lines that were changed by that commit. Is that clear? Does that make sense?
Yes, ma'am.
Okay. So if you're following along, you can go to GitHub yourself and see if you can see these commits as well. And one interesting thing about GitHub is that it can actually, so remember when Prabita said, sometimes you might want to go back in the history and see what your files look like at that point. You can actually do that on GitHub. So in this button here that says browse repository at this point, what that means is that if you click here, it will show you what the files look like at that point in history. So you can see that this file, the README file, actually does not have that third line that I added. So you can jump to any commit that you have in history, and then you can go look through your files and see what your repository looked like at that point in time. Okay. So now I created a commit directly on GitHub. Now, to answer Serena's question from earlier about, oh, will this all, sync up to my local? It won't. Like I said, this is the remote repository, and in my local, you can see I still have the old version because I have to tell Git manually to get the changes from the remote. It won't, this is not like an automatic system. It won't sync changes between GitHub and your local automatically. So how can I do that? So it's a command called git pull. So pull because it's like you're pulling down. So it's like the remote is the cloud and your local is, I don't know, like your ground. So you're pulling from the top. So you're pulling from the cloud into your local. So it's called git pull. So if you do that, it says it pulled from the remote, one file changed. And you can see right here that now my file reflects the changes that I made on GitHub. now my GitHub and local are in sync. And additionally, I'll show you another command, which is called git log graph. So what that will show you is actually the commits. So you can see the same thing that you see here on GitHub. So remember I said a repository is a copy of everything, including the commits, including the branches. So that's why even in my local, I can see the commits now. So it shows me the initial commit, add description, add more description. So you can compare that with what's over here on GitHub on the left. It's the same exact commit history. So we're going to pause here again, and you're going to do the same command on your systems. Oh, I'll show you this as well. So you can see the commits, and the same way, like I clicked into a commit in GitHub and showed you what changed. You can do that on the command line in your local repository as well. So if I copy this SHA, it's an ID. So every commit will have an ID, and you can refer to it by that ID. So if I do git diff, enter that SHA, it'll show me that I added this line in that commit. So it's not as nice and visual as what you see on GitHub, but you can still see the same information, which is that green means something was added, red means something was deleted. In this case, in the README file, these lines were added. Okay, so we're gonna now, you all should try the same commands on your local. So first, pull. So I made those 2 commits. So to pull those changes, run git pull, and then you should be able to see my changes in your code editor. And then run these 2 commands to see the commits and then see the change in one of the commits. And if any of you wants to share your screen, feel free to do that.
Commands are not working, ma'am.
What's not working?
Git pull, ma'am.
Okay, can you share your screen? What does it say?
Okay, ma'am.
Who is going to share their screen? It wasn't working for you?
Charishma, ma'am.
Okay. Is it working for anyone else? Okay. Yeah, my apologies. I missed a step. So can you just do ls to see the folders? Okay. So go into Maristella folder. So cd space Maristella. So that, yeah, thanks for pointing that out. So you have to be in the folder. That's the repository folder for any of the commands to work. Sorry about that, but yes. So any commands, any further commands that we do, make sure you're in that Maristella folder.
Okay, ma'am.
Great. So now you see the changes there. Now you can try the other commands as well. Is it working for everyone?
Yes, ma'am.
Okay. Any questions about git pull and viewing the commit history? Okay, then I will move on to the next step. Okay, so far I created these commits, but I created them directly on GitHub. Now, like I said, it's not common to edit directly on GitHub, mainly because GitHub is not a code editor. I mean, the README file is easy to edit, it's just a text file. But this is the extent of GitHub's editor like this. It's not VS Code. It doesn't have the nice code features and autocomplete and all of that. So no one goes to GitHub to edit code. So I'm going to show you the same thing that I did, which is create a commit, but I'm going to show you how to do it locally.
Ma'am,
Yeah.
ma'am, could you please show us the third command?
Which third command?
Previous. I mean,
Oh. So commit SHA is, so you have to replace this with any of the SHAs from the previous command. So if you did git log graph, you should see these commits. You can copy any of these IDs, and then it's git diff and then the ID.
thank you, ma'am.
Okay, ready? Can I get a thumbs up? I actually don't know how to create a thumbs up on Zoom. So you can just tell me if you're all ready. Okay, shall I move on? Okay, somebody has to share your status because all of you have your cameras off. And I don't know what's going on in your room, whether you're all ready. So one of you, can you please tell me if everyone's ready?
Or maybe everybody should come on camera. Okay. Thumbs up, thumbs down. Charisma. Thumbs up. Okay. Geetika.
Okay.
Thumbs up, thumbs down.
Done, ma'am.
Okay.
Okay.
Okay. So like I said, the next step is I'm going to show you how to make changes locally and commit them. So instead of doing it on GitHub, I'm going to show you what the usual flow is, which is you make some changes in your code editor, and then you will commit them. So what I'm going to do is, so I'm going to edit this README file again. Maybe I'll just add some text here. And then I'm also going to create a new folder and a new file. So I'm going to create my very fancy Python application. All it does is print hello, and that's what I want to commit. So I'm creating my application, and I have the first piece of code there. So I want to add a commit, so a point in time to the version history. So now what I can do is there's a command called git status. So remember, I made two changes. I added this file, and then I also added some text to this file. So when I type git status, so git status is basically it'll show you the status of your local changes. So if I just quickly, if I go back to this this picture here, so you see the local has 3 sections. So working directory, the green is exactly what you see in your code editor. So all of these files, so working directory. So all of the files in the Maristella folder, that is what the working directory means. So anything you change here, that means you just changed it on your working directory. So that's just like how you regularly you would just be editing code, you'd save the files. So that's what that means. So staging area is like an intermediate area. It's like, so sometimes you might not want to commit all of the changes in the same commit. Maybe you just want to add some of the changes, and there's different reasons you might do that. So let's say I'm working on a big feature in my local I'm adding this big feature. It has new files. It has a whole new folder. But while I'm working on it, I see some bug in the application and I just fix it. So in my local, I fix it, but I actually don't want to commit it as part of my feature change because, the feature change, it's separate. It's a new feature and the other change was a bug fix. So they're kind of logically different things that I did. So it's better if your commits are, more contained to specific actions that you took. So what I want to do is I want to commit the bug fix separately, and then I want to commit the feature change separately, right? So that's what staging is for. Staging is to say what you want to commit. So I'll actually show you exactly what I described. So when I did git status, it said I'm on the main branch, and it said the changes, here are some changes that I made. They're not staged. And it also said that I added some new files. So in the R3 folder, I added a file. So what I want to do is I want to add just the new files into one commit. And then I want to add this README change to a different commit. So what I will do is I will do git add, and then what's the file name here? Here we go. So what I'm doing here is I'm saying I just want to add this one file to the staging area. So add, you can see here this arrow. Add just means take specific changes and add it to the staging area. Now if I do a git status, it says changes to be committed, the new file. So I've added just that new file to the staging area, but this other change that I made, which is the small little bug fix that I made to README, I don't want to commit that yet. So it's changed, but it's not staged. So it's in the green area, but it's not in the yellow area. Right now, the yellow area only contains this new file. So whatever is in this new file is the only thing that will be committed when I type git commit. So that's what I'm going to do next. So I'll do git commit. And remember, you have to add a commit message. So I'm gonna add hello program. So now it says I've committed it, and I can check that by doing the git log again. So if you see the commit history, this is just in my local. So I didn't push anything to GitHub. So in my local, I now have a new commit called add hello program, where I added that new file. So now if I do git status again, so what I did, so when I committed it, it took that new file from the staging area and it added it to the commit. So there's nothing left on the staging area anymore. So that's why it says changes not staged for commit. So which includes that little bug fix that I had on the README file. So now I can commit that separately. So I have to add it, move it to the staging area. So I have to do git add, and I'll add the name of the file. And so another, if you remember the git diff command, it showed you the changes. You can actually do git diff -- staged to see what's in the staging area as well. So in this, this file is in the staging area, and it shows me exactly the change I made as well. So now it's in the staging area. I can commit it. I can add another commit that just includes this change to the README file. So again, that adds another commit. If I look at the commit log again, you will see it now has add hello program. Remember, that only had the new file, and then it has another commit called fix README, and that only has this change. Any questions about committing in your local machine? I don't want you to do this yet, but we'll go through a few more steps. But any questions so far? Okay. So if not, then what's the next step? So now I have 2 new commits in my local repository. But of course, if I go to GitHub, you won't see those because I didn't push them to GitHub yet. So this is it's the opposite of the pull command. So pulling is like pulling from the cloud to your local, and pushing is you're pushing your local changes to the cloud. So that's what I'm going to do right now. So if I do git push, it will actually go ahead and push those new commits to GitHub. So if I refresh the page over here, you'll see that it has add hello program, and you can see that that's the new file that I added, the first commit, and then it has the fixed readme commit as well, and this is the second commit that I made in the readme. So when I did git push, it didn't ask me for credentials. I think that was because I already had entered credentials at some point. But when we get to you doing the same steps, it will probably ask you for credentials, and I'll tell you exactly the steps to follow. But usually when you're pushing changes to the remote, you might need credentials to actually push the changes. When you're pulling down, if it's a public repository, you usually don't need any credentials. But when you're pushing, because you're editing something, you usually need credentials. Now, so far, I've just been working in the main branch. And if you remember what Prabita said, the main branch is important. It's usually where your production code is. It's where your live application is deployed from. So you don't want everyone to just keep pushing changes to main, because what if it breaks something? Maybe it's not tested yet. Someone hasn't reviewed it. So it's a bit dangerous to keep pushing changes directly to main. And that's why a very common workflow that's followed by teams is merging workflow. So it is where I'm telling you. So this is the green dots, or main, or your master branch. So in some repository, it will be called main. In some, it will be called master. It's the same thing. It's the trunk of your repository. It's the main branch. And the green dots, so each dot represents a commit. So if you remember, you can see here, like the commit is a dot. It's just the same representation. So just tilted horizontally. So it's like, here's the first commit, then another commit, and then another commit, and so on. But instead of committing directly to main, what you will do is you will create a branch called, maybe I'll call it RT feature change. And then I will add commits to my branch. And then, so that way this is one of the reasons the branching workflow is very great, is because it allows developers to experiment. You don't have to be afraid of breaking the master branch, breaking the production code. You can, kind of create your own safe space where you can experiment, try different things, try your feature. Maybe if the feature doesn't even work, you can just discard the branch. You don't have to merge it back into master. You can just start over from scratch and create a new branch, right? So you would create a branch, you would make your changes, commit to that branch, and then make more changes, commit to that again. So sometimes features can take, days or weeks to develop. So you don't want to merge into master until it's fully ready and you fully tested it locally, make sure that it works. So you want to still have a version history in your branch, so that in case you want to go back to a previous version that was working. So this is all your experimental feature branch. So you can still have commits and versions in your feature branch. And then finally, once it's ready, then you merge it into master. And in the same way, someone else might have their own feature branch. Maybe they're working on a completely different part of the application. So they create their branch, they make commits to it, and then they merge it in. And then someone else might be just working on a very small bug. They're going to create a branch, just fix the bug, create a commit, merge it into master. So this is a very common workflow that you will see in team-based repositories. And so that's the next step that I will walk you through. One more thing that I want to tell you before we proceed. So let's say I create this feature branch. I create my feature, it works, and then I want to merge it in. Now, because like we said before, the master branch is very important. You don't want to break master. You want to make sure that nothing that you're trying to merge into master will break it. So that means this section here, there's going to be, you don't want to just allow anyone to merge into master directly. So let's say the junior developer is working on a feature, they think it's ready, and they're going to merge into master. You don't actually want that, because you want a second pair of eyes, you want some quality checks to pass, you want maybe automated tests to run and pass. So a very common feature that we'll see in a few steps is called a merge request or a pull request. So what that means is that once I have this feature branch ready, instead of me just directly merging it in, I will actually create a merge request. What that means is that I'm telling the team, hey, my feature branch is ready, I want to merge it in. And at that point, usually someone else from your team will review the code. It's good to have a second pair of eyes just to see if everything's working. Is there some improvements you can make to your feature? Also at that stage, you will also be running like a lot of automated tests on the application to make sure nothing will break. And then someone will approve the merge request, and then it will merge. So that's also what we're going to see. So don't worry if all of that is not clear yet. I'll show you exactly what it looks like in practice. But just this is just an introduction to the branching and merging workflow. So this is the visualization of that. You don't want to commit directly to master. So instead, we will create a branch and create commits on it. So that's the next step that I'm going to show you. So in this case, I'm going to go to my local, and I'm going to do git branch. So what git branch does is it's going to create a branch called RT changes. So I can actually list all my branches by doing git branch. And I actually forgot the command. Oh, yeah, there we go. Okay. So if I do git branch all, it's showing me all of the branches. So I'm currently on the main branch. I created a new one called RT branch or RT changes, and I want to switch to that branch first. So in order to switch your branches, you do git checkout and the branch name. And it said I switched to that branch. And if I do git status here, it'll say I'm on this branch, and currently I didn't change anything in the files. There's nothing to commit. So at this point, I want you to create a branch as well and switch to that branch. So here is the task to do. So any questions about the branching and merging workflow that I can answer? So we will go through the entire process, but if there's any questions you have, feel free to ask.
No,
Okay.
ma'am.
Okay, great. So you can do this, each of you can do this in your local computer. So you can do git branch, and each of you create a branch name. Maybe you can do similar to what I did, put your name and dash changes. That way we have some unique branch names. And then use git checkout to switch to that branch. You can also do, instead of typing 2 commands, you can also do it in a single command. This is like a shortcut. It will create the new branch and it will also switch to that branch. So you can do it either way. Were you able to create your branches? And just so you have the command, you can type git status to make sure you're on your new branch. Are you all able to create a new branch? Anybody?
We are trying, ma'am.
Okay.
Ma'am, done, ma'am. Switch it to branch.
Okay. Wonderful. So you can do this next step as well. So similar to what I did, like just create within the Maristella folder, create a new folder with your name, and then add some files to it. You can copy over some files from your projects. And I'll also add a new file so I can show you the next step. Does everyone have your new folder ready?
Yes, ma'am.
Okay, great. So we're going to do this flow. So each of us is going to have our own branches. We'll commit some files to our own branches, and then we're going to merge it all in. Okay. So make sure you have your folder with your name, and then you can go ahead and do the commit. So I'll just show it to you one more time. So it's the same thing that I did before, but so in my case, what I did was I just added a new file. So similarly, you should be adding new files. So if I do git status, oops, status, there we go. So it says I'm on my branch, and there are some untracked files, which is the new file that I added. And then I will do git add, and then this file name. And what that will do is it will stage that file. So if I do the diff command, I can see what the change looks like. So this is the change that's in the staging area, and this is the change that's going to be committed. So to commit it, I'm going to type in commit, and I'll add a message, add new project. Okay, so now it created another file, another commit, so I can see the commit log again. So I can see that I'm in. So now it says this commit only exists in my branch, right? Because I'm committing from my branch. It doesn't exist in main. Main is kind of frozen in this previous state. The new file that I added and the new commit I added is only in my branch, and that's what I want to see. So you can all follow the same steps, and here are the commits you can type in to do that. Just a note, so I did git add, and then I added the name of the file. But if there are a lot of files, instead of doing add for each file, you can also do git add -- all. That will stage all of the changed files. Serena, Prabita, are we doing okay on time? Do we have any specific cutoff time for this workshop?
No, there isn't any time restrictions, but then it also, I mean, I think we are way past our 1 hour time.
Yeah.
Unless you have other commitments or, you know, I think the
I think
girls.
it's really late for Aarti. Until late Aarti, it's almost like past 1 o'clock. It's
It
1 o'clock for Aarti. So let's be
is.
mindful of that. And I think you guys need to figure out what might be a good stopping point. And if it makes sense, Aarti and Prabita, do you guys think for the next steps, you guys can just record the steps and then send it to them and then let them do it? I'll leave it up to you guys. Or Pravita, can you take over? It's up to you guys.
How much
I'm okay
more?
to continue. I'm a night owl. I sleep pretty late anyway. Although if I say something wrong, I'm gonna say it's because it's late.
How much more
Uh,
time do you need, Aarti?
so we're gonna push the branch, then create a pull request, and then approve each other's pull requests. And that's really just push, create a PR, merge. I think it should be okay. There's cleanup, but that's okay. That's just deleting some branches.
Are we at a good stopping point, Aarti, where we are right now with what we have done?
It's
Is it a decent spot to cut off or
we can, but it's also okay if I mean might be okay to finish everything as well. Well,
okay,
actually, what
it's up to
is
you? Because
yeah.
you're the one at 1:30.
That's okay, as long as it doesn't go beyond 2. That's when I'll be sunsetting, I think.
Okay. Why don't we do a hard stop at 2, no matter where we are, and
Yeah,
then you can record or something and send it out, and then the girls can pick it up from there. How's that?
yeah. Okay,
Okay.
that sounds good.
Thank you, Arthur. Appreciate that.
Yeah. Okay, how's everyone doing on this task? Have you been able to create a commit?
I think all of you need to respond faster. Otherwise, we're going to just wait for your response time. So one of you can take the lead and respond for everyone if everybody can't unmute and speak. So who is that going to be? Gitika, Charishma, one of you? On whose computer are you doing this actual practical thing?
Ma'am, the first three commands worked. Ma'am.
First 3 commands worked?
Yes, ma'am.
Okay. Are you having any trouble with this one? Or you just haven't tried it yet?
Ma'am, what should be written in the place of message? Ma'am?
Oh, instead of message, you can say something like add. You can add if you're adding your weather app, you can say add weather app. Or if you're adding your game, you can say add interactive game. Or this song lyrics extractor.
Ma'am, it's not working.
Okay, what does it say? Can you share your screen?
Yes, ma'am. Ma'am, now it's done.
Okay, you got it to work?
I just changed the directory, ma'am.
Okay. Yeah, make sure you're inside the Maristella directory for any of the commands. So, does it work for everyone then?
Yes, ma'am.
Okay, great. Great, you all created your first commit. Congratulations. Okay, so next thing we want to do. So you've now created your commit. You know, you added some changes in your working directory. You added it to staging, and then you committed it to the local repository. So now we have to push to the remote repository. So it's the commit that I showed you before. Actually, it's slightly different because I'm in a because we created new branches. So if you go to GitHub, there's only the main branch. There's no RT changes. There's no charisma changes. There's all of the branches that we created, it doesn't exist. So actually, in order to push this new branch, we have to add some extra details to the command. So my branch was called RT-changes. So instead of when I pushed the main branch, I just did git push and it automatically pushed it to the remote. But because I want to create a new branch in the remote, I have to add these extra arguments. So origin usually just means the remote. So origin is like a reference to the GitHub repository. So what I'm saying is that push this branch, but push it to GitHub, and create a new branch on GitHub called the same branch name. So if I do that, it will, oh, it appeared immediately here. It said I pushed 2 seconds ago, and this is the branch name. So I now have a new branch on GitHub. So you can see here, there are now 2 branches. That's the main, and then there's the one that I just created. And if I see the commits on the one I just created, it has the new file that I added. And this file is only in my branch, but because I pushed the branch, it now shows me, I can now switch between the branches on GitHub and see the different files. So this is also another common thing. So you'll have, so many different feature branches. Everyone will be working on their own features. So you can easily come to GitHub. As long as everyone has pushed their changes to GitHub, you can come here and see the different branches and see the work in progress that they're doing. So I can go see the commits that are in my branch here. So like I mentioned before, when I did a push, usually you will need some credentials. In my case, the credentials were already set up on my computer, so it didn't ask me. But when you do this step, it might ask you for username and password. So the next step is this one. Here we go. So this is the command that you should run. And when you run this command, I think it will ask you for username. The username is your GitHub username, and password is the personal access token. So not the password that you used to log into github.com, but in the prerequisites, there was a step asking you to create a personal access token. That's what you should use for your password. So it will look something like this. So the token will look something like this. It'll be GHP underscore some long string. So make sure that you type your username and then your password is this token. So you can go ahead and try this command.
Ma'am, can you please repeat what we should written on the password?
Do you remember that in the prerequisites there was a requirement to create a personal access token? So you would have gone in here to developer settings and created one. Did you all do that?
Yes, ma'am.
Okay, do you have that token that it created?
Yes, ma'am.
Okay, paste that token. That's your password.
Ma'am, it shows that the incorrect username and password.
Okay, can one of you share your screen then? Oh, no. So when you type this command, does it ask you for username and password? Oh, I see. Okay. 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 In that case, you can type in your regular password and see if that works. Okay. Yeah, you can click authorize. I'll just open the repositories. Okay. Okay, read and write. Okay, that's good. Yeah, you can click authorize. So there are different ways to authenticate with GitHub when you need to push code. I wasn't sure exactly what your Windows systems would do. So on my system, I just had to enter username and my token. But on your computer, it looks like it asks for something else. Okay, so if you go back to your code editor, does it show you anything? Unable to access. Okay, is everyone getting the same error?
Yes, ma'am.
Okay. And the token doesn't work if you type that in. Is that happening for everyone?
Yes, ma'am.
Okay. Okay, then we'll have to do this step at a different time. I'll see what I can find about how to authenticate with Windows correctly. Okay, that's unfortunate, but I can still show you the rest of the steps on GitHub and how that would look. So the next step is pushing to the remote repository. So that's the step I completed. It's not working on your systems. We'll come back to that at another time. I will send you some resources to try to see if we can make that work. But the next step after pushing the branch is to create the pull request. So remember what I said. So when you do your feature branching and merging workflow, instead of me directly merging into master myself, I have to create a pull request so that would give other developers on my team a chance to review my code, approve my code. It will also give, usually in a lot of companies, when someone creates a pull request, like GitHub will automatically run some quality checks, like it will run security scans, it will run automated tests, it will check that the code is formatted. So those will also happen. So in this case, so what I did was I clicked the create pull request button. And what it's saying here is that I want to merge RT changes to main. And I can add a title, add new project file, that seems fine. And usually if it's a big change, I should add a description, maybe add some screenshots of the new feature that I added. So this is a place to describe, really add details about the change that you're adding. Even if it's just a small bug fix, you can add some details about what was causing it, what you did to resolve it. So this is where you would type all of that in. And on the right, you can see there are some options. One of the common options you will use is
I think we can't see your screen.
Oh no, sorry. Okay, I will start over. Okay, can you see my screen now?
Yes, now we can see.
Okay, okay, thank you, Serena. Okay, so on GitHub, I can see the branch that I pushed. So I want to create a pull request so that I can complete this workflow. So I have my branch, it's now on GitHub. I want to merge it into main. So in order to do that, I have to create a pull request. And the reason I have to create a pull request is most teams will not allow me to merge it myself. I cannot just go and, even though my feature is ready, it's all working for me. Generally, companies will not let you merge it directly to master because master or main, because the main branch is important, has to be protected. You don't want to break anything. So you want to have some quality checks before someone merges their code in. So that's why I have to create a pull request. So you can see here, it says I'm creating a request to merge from my branch, RT changes, to main. So that's the direction that I want to merge my changes. And I can add a title. It already added a title based on my commit name. And then here I can add more descriptions if I wanted to add a new file that prints a line. But in general, you would be adding more descriptions here. Maybe you describe the changes you made, add some screenshots, and all of that. And here you can select who you want to review. So that is, so if we're working in a team together, maybe Afrida is the one who is most familiar with this part of the application. So it'd be good if she can review it. So because, maybe she knows more about this specific part of the application. She's worked on it before. So I might select Afrida to review my code. So this is, again, it's another quality gate. You want your peers and your colleagues to review the code so that, you have a second eye. Maybe they can see if I've done something wrong, or they can suggest different ideas or different ways of doing what I'm trying to do. And then I will go ahead and create this pull request. But you can also, so when you're creating the pull request, it will actually also show you what's going in that pull request. So if there were multiple commits that I was adding, it will actually show me all of the commits. And it will show me all of the changes from all the commits. So it's all of the code changes that I'm trying to merge into main. So in this case, it was just one line. So I'll click create pull request. And you'll see in this pull request tab, it's created a new pull request. So if you click on pull requests, so pull requests, it will show you all of the pull requests that are open. So, if we had gotten all of your pushes to work, each of us would have created a pull request and you would see all of them here. And this is where, Afrida would go in, she would go to the view the files that are changes. And this is where, the reviewers can go and check the changes line by line, or see if my formatting is correct, see if I've introduced any bugs. And it says here, one pending review. Usually right now, my repository does not have any restrictions on whether I can merge. Usually this button will be disabled because there'll be a requirement to have at least one person approving my changes. So, Afrida would have to go view my files, view the changes, and then leave a review. So she could add comments on my code, she could approve it, or she could request changes. Like for example, if I wanted to add a comment on this code, I can add that here. Like this line is wrong. I can definitely do that. Or like if Afrida was reviewing my code and she wanted to say that, hey, there's something wrong with this particular line, you need to change it this way, she can add a comment here. And then I can reply and say why I did it this way, and we can have a discussion on the code changes. So this is a whole, it's a whole workflow, you know, where it's kind of it's a very team-based workflow. You're getting your colleagues to review your code, you're having discussions with them, and all within GitHub and all contained in this pull request. So it's a pretty nice interface to be able to click on specific parts of the code and have discussions around that. So once someone has reviewed, they will click approve. And only then will I be able to merge usually. In this case, in our repository, I didn't set up those restrictions, so it's just going to let me merge. So I'll just show you how that works. So I will go create the merge. It will just do it automatically. And it says I merged. And you can see that this pull request is now merged in. So that's how I have completed this flow. So now all of the changes that I made in my branch are now in main. So if I go to the main branch here, the main, and I click the commits, I can see that the commit that I adding that new project file is also in main. And it also creates a merge commit. So in this diagram, you see this blue was the commit that I made in my branch, but this green dot, which has, you know, all these lines going in, that's called the merge commit because we're merging my change, my branch into the main. So that's why it creates a merge commit. It'll show you the same changes, but it is a special type of commit. Any questions on that process?
No, ma'am.
Okay, great. And at this point, you know, this branch is no longer useful. I can go and delete it. I think there's a way to delete it in GitHub. I can just delete it. This one deleted locally, so I can also go to my local and delete it here if I wanted to. So that's just some cleanup because usually you'll create branches for a specific feature. You won't just create a branch called your that's called your name, and you're not going to reuse the branches. They're meant to be kind of throwaway. Like you create a branch, you work on it, you finish the feature, you merge it, and then you delete it, and then you go create a new branch for a new feature. I just wanted to show you a few other things in GitHub that's common to use. There's an issues tab. So issues is like reports, like bug fixes, and well, not it's for someone external to your team or within your team to request features. So it's like if there's a bug that I find in say the song lyrics extractor. So say you pushed your song lyrics extractor to this repository, and I find a bug where it's not handling a language correctly. So I can file a bug report saying bug song lyrics extractor does not work in Hindi, right? So I'm just reporting an issue that's in the application. So it's just a way to track tasks that we might have to do as a team so that we don't lose track of, you know, bugs or features or little enhancements that we might want to add. It's a way to organize the project and the tasks on your project. And here in the description, maybe I will add more details on what I mean by this bug, and I can create it. And you can create bugs. You can also create enhancements. I can create an issue saying I want an enhancement where I want the weather app to show me temperature in Fahrenheit. Like that's not a feature that exists, but I want that feature, so I create an issue here. So the reason to create issues is to track, again, it's to track potential new tasks for the team. And I'm gonna actually switch to maybe a different project to show you what it looks like in a real project. So this is GitHub's the open source repository for Matplotlib. So if you remember the first team that built the weather app, they used Matplotlib to draw the graph. So this is a Python library. So to use it, you just do pip install Matplotlib and it'll work. But this is the actual code behind the library. So it's all open source. You can view it. So you can do the exact same things that we did. Like you can clone this repository if you want to see the code. You can even submit a pull request to them and see if you ever wanted to contribute to this project, you could do that. But this is an example of an open source repository, what it looks like. You can see there's a lot of code in here. There's a lot of folders, a lot of files. And if you see the issues list over here, you can see a lot of people have because this repository is public, anyone who is using this library can actually come and file up, create an issue here. Maybe you try to use it and you found that a feature wasn't working. You can actually come here and create a new issue and report what you were seeing, so that the team that's maintaining this project is aware that there's a bug and maybe they can prioritize fixing it. So here's an example that someone created a bug ticket. They created a big summary, they're showing you exactly the code that they use and how to reproduce that bug. And then again, it provides a space to have a discussion as well. So this report was created by some community member, maybe someone like you who tried to use the library, found the bug, they created this issue, and then someone from the Matplotlib team will reply to it, and maybe there's a back and forth. So that's a pretty useful feature in GitHub. It's a way to track the work, and you can also reference the issue when you're creating a pull request. So if you create a pull request to fix this particular bug, in the description you can type in this ID, and it will actually manage. It will directly link to this, and it will also close this issue when you merge that pull request. So that's one of the things I wanted to show. And another one that I wanted to show is one of these pull requests. So let's just take a look. So you can see here what I meant. So someone here has tried to create a merge request. They did something on their branch. They're trying to get it merged. They wrote up a description, and now it says review required because they can't just directly themselves merge it in.